If A is a constant vector, prove that gradient of r dot A equal to A. Suppose r is the position vector and A is the constant vector. Constant vector means a vector whose magnitude and direction are constant at any position. And suppose the position vector r is equal to I cap x plus j cap y plus k cap z, and the constant vector A is equal to I cap ax plus j cap ay plus k cap az. So if you take the dot product of the position vector and the constant vector, that is r dot A, this will be equal to I cap x plus j cap y plus k cap z dot I cap ax plus j cap ay plus k cap az. If you take the dot product, only you have I dot I, j dot j and k dot k exist, and other dot product like I dot j, I dot k, they will be equal to 0. So r dot A will be equal to ax into x plus ay into y plus az into z. So if you take the gradient of r dot A, gradient is nothing but I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z, because I have told you gradient of a scalar is equal to, always you take gradient of a scalar, because you cannot have gradient of vector. Gradient of scalar is equal to the del of the scalar quantity. Here this is a scalar quantity, this is a scalar quantity, so this is the del operator, and del operator when operates on this scalar quantity, it will give you gradient. So gradient of a scalar function is equal to del of the scalar function, and del is a vector. Remember, del operator is a vector, and which operates on a scalar quantity, that gives you a vector. So del operator of this scalar quantity will be equal to I cap ax, because del x with respect to x will be equal to 1. Similarly, j cap ay plus k cap az, and this is nothing but your constant vector A. So gradient of r dot A will be equal to the constant vector A.